the sum of the terms in a geometric progression. Since we're looking for a common ratio, we usually assume that r is always positive. Okay? The common difference could be positive or negative. Common ratios tend to just be positive because if r is negative, that runs into some difficulties because r is negative for even powers of r. It's positive for for odd powers. It would then still be negative, and that would be what we often call an alternating sequence, and that's not exactly a geometric progression, and it often causes issues on how to figure out the sum accurately. There are methods of doing it, but it's more complicated than using the formulas we have here. But so the circumstances we look at is if r is not equal to 1, it means that the common ratio is not 1. I use the formula a times 1 minus r to the n power all over 1 minus r to calculate the sum of that geometric sequence. If r happens to be 1, it just becomes n times a, because if I'm going to basically have my common ratio is 1, and I'm going to have a sequence of all the same number. For this example, though, we didn't have that. So now you're asked to find the sum of the first 15 terms of the following sequence. And notice there's only one formula for this. So it doesn't matter that we already know that the 15th term was that value we found in the previous example. So that doesn't mean anything to us. We don't really make use of that. We only have one formula here. So S of 15 equals 9 times 1 minus 5/3 to the 15th power all over 1 minus 5/3. The 1 minus 5/3 to the 15th power becomes approximately negative 2125.822491. And you deal with a lot of negatives on this, but they do cancel each other out because you're going to be dividing two negatives. So if I do 9 times that divided by negative 2/3, I get 28,698.6 approximately. And that would be the sum of the first 15 terms of the sequence.